very interesting question today. Today, we're going to also look at the MIT 2023 Integration B regular season question, and this is problem 17. And as I mentioned previously, this week, we're going to be focusing on flow function and how to integrate them. So a problem today is the integral of -1 to the power flow function of x plus flow function of x over root 2 plus flow function of x over root 3 from 0 to 5. And so this problem, for those of you who are well versed with exponents, can also be re-expressed as the integral of the product of -1 to the power flow function of x times -1 flow function of x over root 2 times -1 to the power flow function over root 3. So let's look at what flow function of x really means. So if we have our axes here, x and y, and as you move from 0 to 1 for the flow function of x, and since we have our interval 0 to 5, from 0 to 1, the value in that entire domain is going to be 0. Then when you move from 1 to 2 in that entire stretch, the value of y will be 1. From 2 to 3 in that entire stretch, the value will be 2. From 3 to 4 in that entire stretch, the value will be 3. From 4 to 5, the flow there will be 4, and that will be it. Obviously, at 5, the value will just be a single value of 5. And then for y is equals to x, flow function of x over root 2, we have to introduce intermediaries between the 0 and 5 integration domain. So we have to have root 2, then 2 root 2, and then 3 root 2. So such that from 0 to root 2, that's when obviously x is 1 at x is equals to root 2. In that entire stretch, the value of y is 0. Then from root 2 to 2 root 2 in that entire stretch, because it's from that region that now it transitions to 2, but in that entire stretch, now the flow will be 1. And from 2 root 2 to 3 root 2, in that entire stretch, the function will be 2. And then from 3 root 2 to 5, which is the end of our integration domain, the value there will be 3. And then for y is equals the flow function of x over root 3, we have to introduce some intermediaries there. So, and that will be root 3 and then 2 root 3, because 3 root 3 will fall out of the domain, the integration domain there. So from 0 to root 3, our y will be 0. And then from root 3 to 2 root 3, the value there, y becomes 1. And then from 2 root 3 to 5, the value there is going to be 2. The flow value is going to be 2. So what that means is that if we are looking at the product of -1 to the power root of the power flow function of x times -1 times the flow function of x over root 2 times -1 the flow to the power flow function of x over root 3, we can look at this numbers separately. So first of all, if we begin with y is equals to -1 the power flow function of x, from 0 to 1, we're going to have -1 the power 0, so number the power 0 is 1. And then from 1 to 2, because the flow function there of x is going to be 1, -1 the power 1 is going to be -1. And then from 2 to 3, since the flow function value there is 2, -1 squared is going to be +1. And then from 3 to 4, since the flow function value there is 3, Then negative 1 to the power 3 is going to be negative 1. And then from 4 to 5, the floor function value there will be 4. So in negative 1 to the power 4 is going to be positive 1. And then for y is equals negative 1 to the power x, the power root 2. Again, we're going to introduce intermediaries there from 0 to root 2, since the value of the floor function there is going to be 0. The value of y is going to be negative 1 to the power 0, which is going to be positive 1. From 2 to 2 root 2, since the value of the floor function there is negative 1, negative 1 to the power 1 is going to result into negative 1. And then from 2 to 3, since the floor function value there is 2, negative 1 squared is going to be positive 1. And then from 3 root 2 to 5, since the value there is 3, negative 1 to the power 3 is going to be negative 1. The same thing would apply to our y is equals negative 1 times x, to the power x over root 3. We'll introduce our intermediaries there from 0 to negative to square root 3. Since the value is going to be 0 there for the floor function, negative 1 to the power 0 is going to be positive 1. From root 3 to 2 root 3, the value there is going to be 1 for the floor function, and so negative 1 to the power 1 is going to be negative 1. And then for the last rate there, 2 root 3 to 5, since the floor function is going to be 2, negative 1 squared is going to be positive 1. Now we're going to multiply these independent functions in their respective regions there. So we'll have the final product plot, and then we're going to divide it into the separate domains that we have different combinations of negative 1 and positive 1. So for example, from 0 to 1, since everything is positive 1, the value there for the product is going to be 1, positive 1. And then from 1 to root 2, since y to the power root floor function of x is negative 1, and the remaining still positive 1, the product was resulting to a negative 1. And in the next section, since we have two negative 1s, the first and the second, and then the third is positive, it will be a positive. And then we continue like that for the rest of the subdomains. And so if we say this is area 1, area 2, area 3, area 4, area 5, area 6, area 7, area 8, area 9, area 10, and the areas below the x-axis are going to be negative. The ones above will be positive. So area 1 is going to be 1 because it stretches from 0 to 1 times the height, which is going to be positive 1. Then area 2 is going to be x-axis root 2 minus 1 times the height, which is 1, but it's in the negative side, so we attach a negative 1. Area 3 is in the positive direction, so it's root 3 times root 2 times 1. And then area 4 is positive 2 minus root 3 times 1, but in negative direction, so negative 1. And then area 5 is root 2 minus 2 times 1 in the positive direction. And then area 6 is 3 minus 2 root 2 times 1 in the negative direction, so negative sign here. Area 7 is 2 root 3 minus 3 times 1 in the positive direction, as you can see here. Area 8 is 4 minus 2 root 3 times 1 in negative direction, as we see there. Area 9 is 3 times root 2 minus 4 times 1 in the positive direction. And area 10 is 5 minus 3 root 2 times 1 in the negative direction. So when we add all those areas, area 1, 2, 3, 4, 5, 6, up to 10, as we see here, the final value is going to be negative 21 plus 8 root 2 plus 6 root 3. Thank you very much for your kind attention. This has been a very interesting problem, but very tricky at the same time. So for those of you who would like to receive further notifications from us on how to solve this very tricky problem, please subscribe to our channel. This is Everyday Mathematics. We love to solve the harder problems. We also enjoy the beauty of the simpler problems. Thank you very much, and see you next time. Thank you.